Welcome on this tutorial. In this tutorial I am going to discuss about different detectors used in gas chromatography. Gas chromatography is a technique of separation of molecules from organic and inorganic compounds based on the properties or characteristics of volatility and polarity. In this case, two phases are there according to construction. One is mobile phase, another one is stationary phase. The mobile phase is the carrier phase, which normally carries the sample to be tested, and stationary phase is the column. When the gas with carrier will pass through the column, according to the properties of volatility and polarity, different molecules or different component of gases will take different time to reach at the output of the column. Means, according to the property, different components will interact with the column differently. So, at the column output, different component will reach at different times. Those components are then detected by different detectors. Now in this section, I will explain about different detectors. I am entering into the discussion. Please subscribe. It will grow my interest to prepare more tutorials on different important topics. Entering into the discussion. First, I am explaining about flame ionization detector. Flame ionization detector is mainly used for organic compounds. In this case, flame is produced with the presence of hydrogen and air. Hydrogen used as a fuel and air used as an oxidant. The whole detector system is placed into its own oven, which is hotter than the column temperature, to stop anything condensing in the detector. The temperature of the detector is higher than the column temperature, so that all the samples will be in gaseous form. While there is no organic coming from the column, then the flame will be produced only due to the presence of hydrogen and air. Now when sample of organic compounds will enter into the flame ionization detector from the column, then that sample will burn and produce small amounts of ions and electrons. Ions means positive ions and negative ions. In the detector, there are two electrodes, one is cathode, another one is anode. This anode is positive electrode and cathode is negative electrode. In external circuit, anode is connected with positive terminal of the battery and negative terminal of the battery is connected with the cathode. Now in this case, this cylindrical jet, this is the anode, and this upper cylinder acts as a cathode. When sample will enter through the jet and burnt by the flame, then that sample will form positive ion, negative ion and electron. Now all electrons and negative ions will be attracted towards anode, means this will be attracted towards anode plate and electron will be attracted towards this anode plate, and all the positive ions will be attracted towards cathode, as cathode is negative electrode. When the positive ions will be attached with the cathode, then positive ion will collect electron from the cathode and it will be neutralized. For the case of anode plate, anode will attract the electron, as well as all the negative ions will come to the anode. Negative ions will release electron at anode and it will be neutralized. Cathode will release the electron, anode will gain the electron. So there will be electron flow from cathode to anode inside the detector, and at the outside from anode to cathode there will be a flow of electron. Means at the outer circuit there will be flow of current. Now the magnitude of that flow of current will depend on formation of positive ion, negative ion and electron inside the detector. Now the strength of ion formation will depend on concentration of the sample. So current through the circuit ultimately will give the indication of the sample to be detected. The magnitude of the current will give the strength of the sample, means concentration of the sample. So this is how flame ionization detector works. What are the different advantages and disadvantages of flame ionization detector? Flame ionization detector is inexpensive to operate and acquire. It is having low maintenance requirement. Apart from cleaning the jet and replacing the jet, this detector requires very little maintenance. Regarding construction, it is rugged construction. FID is relatively resistant to misuse. It gives linear output. Disadvantages of FID: The most disadvantage of FID is that it destroys whole sample. Means the sample which is coming out from the column, all amount of sample are destroyed by the flame. If we want to send this product to the mass spectrometer for further analysis, then never we can use flame ionization detector. Another disadvantage is that different functional groups like carbonyl, halogen, amine, this type of groups cannot be detected by flame ionization detector. Now I am explaining thermal conductivity detector. Thermal conductivity detector is based on Wheatstone bridge. These are 4 arms of the Wheatstone bridge. Through opposite 2 arms, reference gas is passed, and through these opposite arms, reference gas with sample is passed. In this thermal conductivity detector, normally helium gas is used as mobile phase. This detector is based on comparison of 2 gases. One is carrier gas and other one is mixture of carrier gas and compound. Now thermal conductivity of different gases are different. So a change in composition of gas causes change in thermal conductivity. Say for a resistive element, when current will pass through a resistance, temperature of the resistance is increased and it will produce heat. Now if the conductivity of surrounding atmosphere is higher, then heat dissipation will be higher. If the conductivity of surrounding atmosphere is lower, then the heat dissipation by this resistance or heat dissipation from this resistance will be lower. Using this property, thermal conductivity detector produce output. What is happened here? The reference gas is allowed to pass through 2 opposite arms of the Wheatstone bridge, and through other 2 opposite arms, carrier gas with sample is allowed to pass. When no sample gas is present, at that condition the bridge will be balanced because all the 4 arms will be attached with only carrier gas. Now when sample gas will be there, when sample gas will be with the carrier gas and it will pass through these opposite arms, according to the property, conductivity is reduced. Means presence of solute normally decreases conductivity to the mobile phase. So when conductivity will be decreased, what will happen? When the surrounding atmosphere conductivity will be decreased, then heat dissipation will be decreased. As heat dissipation will be decreased, temperature of the resistance will be increased. Presence of solute decreases the conductivity. So when conductivity decreases, heat dissipation by the resistance will be decreased. When heat dissipation will be decreased, then temperature of resistance will be increased. When temperature of the resistance will be increased, then the value of resistance will be increased because the resistance formula RT is equal to R0 into 1 plus alpha into T, where T is the temperature. So when the sample will be passed through these opposite arms, conductivity of the surrounding atmosphere will be changed. So heat dissipation from these arms and these arms will be decreased. As heat dissipation is decreased, temperature of this arm and this arm will be increased. As temperature is increased, the resistance value of this arm and this arm will be increased. Means Wheatstone bridge will be in unbalanced condition. Now the degree of unbalance of this Wheatstone bridge will depend on the concentration of the sample to be tested. Means if the compound concentration is higher, then Wheatstone bridge will provide higher output. If the concentration of the sample is lower, Wheatstone bridge will provide lower output. Amplifier output is the ultimate indication of unknown sample to be tested. Now different advantages and disadvantages of thermal conductivity detector. Thermal conductivity detector is non-destructive in nature. Means if we want to use the sample again for further analysis, then we can collect this sample. It is very simple and rugged construction. It is inexpensive. It gives linear output for large range, gives accurate result, and this thermal conductivity detector is universal for the case of organic compound and inorganic compound. What is the disadvantage? Sensitivity is very low. Output is affected with the variation of temperature and flow rate. Thermal conductivity detector is very less sensitive if we use the nitrogen and carbon dioxide as the carrier gas. Now explaining flame photometric detector. Flame photometry is based on the measurement of intensity of light emitted when a compound is introduced into the flame. This gives qualitative as well as the quantitative measure. Wavelengths of color tells us what the element is. This is qualitative. Color's intensity tells us how much the element is present. This is quantitative. Determination of sulfur and phosphorus compound is the job of flame photometric detector. As per the construction, flame photometric detector has a flame chamber with this block along with thermal filter and interface filter, and it also having photomultiplier tube. Sample from the column is introduced through this metal heated block. Air and hydrogen mixture will produce the flame. When the sample to be tested is introduced through this block, and when it will attach with the flame, then it will produce light with specific wavelength. Sample will be introduced from the column through this heated metal block. Sample is burnt in the presence of hydrogen air flame. Hydrogen will act as a fuel and air will act as an oxidant. This burning effect will ultimately produce the light energy with corresponding wavelength. For the case of sulfur, the light energy will have 394 nanometer wavelength. For the case of phosphor, the light energy will have 526 nanometer wavelength. The light energy will pass through thermal filter and next it will pass through interference filter. Function of this thermal filter is to allow only visible and ultraviolet rays. Monochromators are normally used as the interface filter. This interface filter will allow light energy with a single wavelength. Say when we want to detect whether there is phosphorus element in the sample or not. So in that case, specific filter or a specific monochromator should be used which will allow only a light energy with 526 nanometer. Now if we want to detect sulfur content, then the monochromator should be chosen such that it will allow the light energy which is having wavelength of 394 nanometer. So ultimately corresponding light energy will pass through the interface filter and that will be detected by photomultiplier tube. This photomultiplier tube will multiply the signal and it will ultimately produce an electronic or electrical output. Magnitude of this electrical output is the indication of the strength of sample to be tested. If the concentration of sulfur or phosphorus is higher, then the output will be higher. If the concentration is lower, then the output will be lower. So output of the photomultiplier tube is the indication of sample's strength. Now what are the advantages and disadvantages of flame photometric detector? FID is very simple. It gives quantitative analytical test based on the flame analysis. It is inexpensive. Sensitivity is too high, even parts per million to parts per billion range. What are the disadvantages? The main disadvantage is that it is very much selective to phosphorus and sulfur. It is the selective detector that is responsive to compounds containing sulfur and phosphorus only. The another disadvantage is that interface filter must be changed between chromatographic runs if we want to detect different compounds. When we want to detect sulfur compound, corresponding filter will be used here. Next time if we want to detect phosphorus compound, this filter should be changed, which will allow light energy with 526 nanometer. Next, coming to electron capture detector. By the name we can easily understand that there will be electron capturing phenomena. In electron capture detector, two electrodes are there into the cavity. One electrode is anode, another electrode is cathode. And there will be a radiation source. Normally nickel 63 is used. This radiation source emits electron. So in normal process, there will be a flow of electron from cathode side to anode side. In electron capture detector, normally nitrogen gas is used as carrier. When simple carrier gas is passed through this cavity, then emitted electron ionize the carrier gas and there will be a constant flow of electron from cathode to anode. So a constant current will be produced through the external circuit. Now when electronegative solute elutes from the column, means the sample which is having electronegativity property that will enter into the cavity with the carrier gas. Due to presence of electronegativity property, it will capture more number of electron. So electron flow from cathode side to anode side will decrease. Means less number of electron will flow from cathode to anode inside the cavity. So current flow through the external circuit will be decreased. This decrease in current serves as signal. So if the concentration of the sample to be tested is higher, then electron capturing capacity will be higher. So number of electrons from cathode to anode will be very less. According to the concentration, if the concentration of the sample to be tested is higher, the current flow will be lower. If the concentration of sample to be tested is lower, then current will be higher. So the magnitude of the current will give the ultimate indication of the concentration of the sample to be tested. Now what are the advantages and disadvantages of electron capture detectors? This is very simple in construction, and most important advantage is it is non-destructive. That is, do not have any effect on the sample. If we want to collect the sample, then we may collect it and we may reuse the sample. This is highly sensitive for the case of electronegative compound, and this electron capture detector can be 10 to 1000 times more sensitive than flame ionization detector and 1 million times more sensitive than thermal conductivity detector. What are the disadvantages? It is very much insensitive to amines, alcohols and hydrocarbons. It is having very limited dynamic range. It is limited only those groups or those samples which is having very much electron affinity. Means this is highly selective. So I have explained about different detectors used in gas chromatograph. First I have explained flame ionization detector, next thermal conductivity detector, next flame photometric detector, and last I have explained electron capture detector. There are other detectors also. Among them one is mass spectrometer. I will discuss mass spectrometer in a separate tutorial. I wish you will get an idea about different detectors used in gas chromatograph. Please click on subscribe button, put comments and queries in comment section.